What's up, Calc gang? All right, we got a problem here, and it wants us to find our equilibrium points, classify them, make a phase line, and then graph a YT graph of what it would look like, basically, with all the different functions. So let's go ahead and do that. Okay, so let's go ahead and draw a graph. That's what we should start with. So this is y, and this is y prime, which is a function of y. Okay, we want to find when this is equal to 0. So right out the bat, see that this is equal to 0 there, and then we have functions at 1 and -1, right? Okay, pretty simple. But we need to know how this works. And to figure out how this graph is going to actually look, we need to do a couple things. One thing I like to do is I like to say, if we factor this out, what would our highest exponent be, right? It would be y to the 4th. And just positive y to the 4th. And we know that y to the 4th is going to kind of look like this. So we know that it's going to go out this way on the ends, and like that on the ends. Okay, good, we figured out one thing. So let's go ahead and figure out another thing. Okay, so it's going to approach like this, basically. So let's see what happens in between these 2 points. So we know that it's not going to cross 0, so basically if I'm kind of stumped, I just like to plug in a number and see what would happen. So this is 0.5, so let's plug in 0.5. So 0.5 minus 1, this is going to be a negative number, times 0.5. This is going to be negative, so it's going to kind of go negative to there. And then if you plug in negative 0.5, it's going to do the same thing because the y's are squared. You know that this is going to be like a mirrored graph. So it's going to kind of do this too. But then at this point, what's going to happen? Well, you can see what's happening. If it's on the bottom here and it's on the bottom here, it's just kind of go around like that. Okay, so that's how this graph looks. Very, rough drawing, but that's what you need. That's all you need for this kind of problem. Okay, so then we need to draw our phase line. So here it's above. If it's above the graph, the line's going to point to the right. And then here it's below the graph, so the line's going to point to the left. And then here again, it's below the line, it's going to go to the left. And then here it's above the line, so it's going to go to the right. So let's classify these points. So this one, the lines are pointing inward. That means you're going to fill in the bubble because, the lines are pointing inward, it's going to fill in the bubble, med school, do it in your head, right? Okay, and if it's this is stable, right? At y is equal to -1. Okay, this one here, we have one pointing in and then one pointing out. What that means is it's semi-stable, it's half filled. Pardon my awful handwriting, but you know what I'm saying. And in this one, the lines are both pointing out. That means that it's going to be white on the inside, and that means it's going to be an unstable point. I'm totally curving, but there you go, that's the 3 things we have. So now we can go ahead and draw our graph, because we have all the information we need out of this phase line. So I like to start by drawing my phase line again. So here is y is equal to 0. Here's y is equal to 1. And this is y is equal to -1. So at -1, it's stable. Pointing up, pointing down. This one is semi-stable, it's pointing down. Like this. And then this one is unstable, it's pointing up. Okay, so let's go ahead and draw our ty graph. So we have t on this axis. We have y on this axis. And we're going to have our equilibrium solutions. So these are what our line's going to look like. Actually, I should do this in a different color, shouldn't I? Yeah, I'll make this a bit easier. Okay. So it'd be like this, basically. And then also we're going to have one here. Okay. So then in between these, well, let's see, how are these arrows pointing? So this is pointing down. So this is going to be, kind of pointing down. A solution that starts in here is going to look something like this, where it approaches this going negative and approaches this going positive. And then here, this is also going down, so it's going to be the same kind of thing, where the solution kind of curves downward like that. Here, the line's pointing up, so you can see that our solutions, oh wow, that's awful, but our solutions would look something like this, where they approach this line. Because they're pointing inward, it's going to go up. And then this one is pointing up. So that means that the lines are going to go like this. They're going to be unstable as they leave that. So, yeah, let me make this a little clearer. Here's our equilibrium lines. And those green lines are our functions. So yeah, that's how you do these kind of problems. I actually really like these. They're pretty fun. It's a little problem. It's like a little puzzle putting it together. And yeah, so yeah, good luck on your calc homework, guys. Or physics homework, or not physics homework. I do too much stuff. Okay, good luck, guys.